Hello, welcome back. This is going to be a video for college algebra. This is going to actually cover section 7-5. Okay. Um, we're not going to do 7-4. The topic for 7-4 is called partial fractions. Partial fractions is a topic that you probably will never encounter until you take Calc 2. Okay, and so if you're planning on a major where eventually you'll have to go through Calc 2, that is a topic that you'll learn about. But even in Calc 1, we never actually use partial fractions. Partial fractions are a technique that you can use to decompose a rational expression into the sum or difference of multiple rational expressions. But long story short, it's not assessed on the dual credit final exam. It never has been. So we're going to skip that. We're going to go straight to 7-5, which deals with the concept of matrices. Matrices, that's the plural of the word matrix. Okay, so what you're going to see today is a matrix and another matrix and another matrix, and we are going to learn how to operate with matrices, how to add matrices, subtract matrices, multiply matrices. So let's start by just what is a matrix. Well, in short, a matrix is an organizational tool. Okay, it's an organizational tool into which you can put a set of numbers or data, and not only can it keep that data organized, but it can allow you to more quickly operate with that set of data. Okay, matrices and various techniques involving matrices are often used to solve large systems of equations. If you remember, the broad topic for this chapter is systems of equations. So matrices are definitely a tool that you will eventually be able to use to solve systems of equations. For now, all we're going to do is we're going to learn, how is a matrix structured, and then how to perform just basic operations on matrices. So first off, a matrix looks like this. Okay, a matrix will have a set of brackets. Okay, and inside those brackets go some numbers. Okay, I'm going to go ahead and I'm going to put some numbers in here. Let's just go 3, 3, 1, 4, 9, 2. Now, I can promise you I made those numbers up on the spot. Okay, they have no real world meaning or anything. But what I want you to do is look at this. This is a matrix. All right, there are 1, 2, 3, 4, 5, 6, what we call elements in this matrix. So each number in this matrix, okay, there are 6 of them, each one of those is called an element. Now, the next thing to know is that the matrix can be divided into a set of rows and a set of columns, okay, or it can be thought in the matrix. The numbers in the matrix can be thought of as a set of rows and a set of columns. Okay, in this matrix, there are 1, 2 rows and 1, 2, 3 columns. Okay, and so what we would say is that since there are 2 rows and 3 columns, we would say this is a 2 by 3 matrix. Okay, that's a 2 by 3 matrix. It always goes rows by columns. Okay, now let's go ahead and talk about the 2 simplest operations with matrices, which would be to take 2 matrices, 2 or more matrices, and add them or subtract them. Now here's the first thing to know. I can only add or subtract 2 matrices if they are structured exactly the same way. The same number of rows and the same number of columns. So for instance, if I wanted to add this matrix to another matrix, or add another matrix to this matrix, the matrix that I add or subtract in a problem with with this matrix has to also be a 2 by 3 matrix. So let's add this matrix with another 2 by 3 matrix. I'm going to go 1, 0, 2, 3, 8, 5. Okay. Now, matrix addition is as simple as anything you'll do all year. If I add two 2 by 3 matrices, the sum of those matrices is also going to be a 2 by 3 matrix. And to get the elements in this 2 by 3 matrix, I simply add the elements, the corresponding elements from each matrix. So, like to get the uppermost, the top left element in the sum matrix, I add 3 plus 1, which gives me 4. To get the top middle element, 3 plus 0 is 3. To get the top right element, 1 plus 2 is 3. And I have the top row of the matrix, that's the sum of these two matrices. Now to get the bottom row, I will add the elements from the two bottom rows here. 4 plus 3 is 7. 9 plus 8 is 17. 2 plus 5 is 7. Okay, so now I have a matrix that represents the sum of these two original matrices. And I'll say it again, you can only add or subtract matrices that have the same row and column structure. Okay, in this case, they're both 2 by 3. And if you perform operations, addition or subtraction, you will get a 2 by 3 matrix as well. Now, caution, that is only true for addition, the operations addition and subtraction. As we'll see when we get to multiplication, I couldn't multiply this matrix by this matrix. The structures of the two matrices don't allow it. Okay, but the similar structure, the 2 rows by 3 columns, is essential for me to be able to add these two matrices or to subtract them. All right, let's introduce something else here. We usually name a matrix with a capital letter. All right, so I might say that matrix A looks like this, 2, 1, 3, 4. Okay, that's a 2 by 2 matrix. And matrix B, remember I name any matrix with a capital letter, so let's say matrix B goes 1, 0, 2, 3. Since matrices A and B have the same structure, they're both 2 rows by 2 columns. I am free to add or subtract those matrices. Addition is commutative when it comes to matrices, and subtraction obviously is not. It never is. But if I were to add these, the result, of course, would be a 2 by 2 matrix. But the real reason I put these two matrices up there was just to show you that we tend to name matrices with capital letters. Now, I'm going to leave the top matrix up there, matrix A, and I want to show you how to take a matrix times just a number. Okay, so I can take a matrix times just a scalar number, no matter what the size or structure of the matrix is. For example, something you might be asked to do is to find 3A. Well, 3A simply means we're going to take matrix A, and we're going to take it times the number 3, which, as you might suspect, just means I'm going to multiply every element in that matrix by 3. So matrix 3A would look like this. Let's see, 3 times 2, 3 times 1, 3 times 3, and finally 3 times 4. Cut that off. And this matrix right here, also a 2 by 2, is the result that I get when I multiply matrix A by 3. So we have talked about the structure of a matrix. It's always the number of rows by the number of columns. So 2 by 2 is the structure for these two. We've talked about how to add matrices. We didn't do an example with with subtraction, but it's the same idea. And we've talked now about how to multiply a matrix by a number. Teddy, how are we doing time-wise?
10 minutes.
Okay. So I think we have time here to talk about matrix multiplication, which is slightly more complicated than matrix addition or subtraction. Now, first of all, let's talk about the structure of matrices that allow for multiplication to be conducted. Well, I want to put a hypothetical set of matrices up here. Let's do this. I'm going to make this a 3 by 2. Okay, so here is, we'll call that matrix A. And I'll call this matrix B. And I'm going to make this a 2 by 3 matrix. So let's go 1, 2, 5, 6, 8, 1. Okay, so can I add matrices A and B? Well, the answer is no, because their structures are not the same. This is a 3 by 2 matrix, 3 rows by 2 columns, whereas this is a 2 by 3 matrix. Okay, so since the structures are not the same, I am not free to add or subtract those two matrices. So let's talk about whether or not I can take A times B or B times A here. Okay, there's a big difference. Okay, multiplication with matrices is not commutative. In fact, oftentimes it's possible to multiply one matrix by another one way, but not the other way. In other words, I might be able to take A times B, but I might not be able to take B times A because of the structure of the matrices. So let's talk about this. Okay, first of all, if I look at this, if I want to take a 3 by 2 matrix times a 2 by 3 matrix, that is allowed. And here's how to tell. Look at the inner numbers. Okay, look at the inner